Hello A&P students, this is Mr. Becker here to discuss the second major tissue type in our histology lab, connective tissues. First, we'll cover the general characteristics we look for that identify connective tissues. Then we'll examine each type of connective tissue and what makes it unique from other connective tissues. All connective tissues contain three elements: a non-cellular ground substance, also referred to as matrix, a set of protein fibers running through that ground substance, and resident cells to maintain the fibers and ground substance. Once we understand that all connective tissues have resident cells, ground substance, and protein fibers, we can understand how connective tissues are organized. Loose connective tissues contain relatively large amounts of ground substance and relatively sparse amounts of protein fibers. This makes it a good packing material, as ground substance tends to be jelly-like and squishy. Dense regular connective tissues have relatively large amounts of protein fibers and relatively sparse amounts of ground substance. This makes it good at resisting forces that are placed on the tissue. Supporting connective tissue tends to have its matrix filled in with a substance that is significantly stronger, allowing it to withstand significant amounts of force and weight that may be placed on it. Fluid connective tissues tend to have a protein fiber network under certain circumstances. The ground substance of fluid connective tissue is liquid most of the time, and resident cells float through that tissue. Our first connective tissue is areolar connective tissue. Areolar connective tissue is a loose connective tissue that acts as a packing material throughout the body. We can see the fibroblast nuclei in the large image of areolar connective tissue and in the image of lamina propria. Large collagen fibers provide some toughness to the tissue. Note how the collagen fibers aren't very clear in the big image. They are so large, it's tough to focus on them. Smaller, thinner elastin fibers run around the collagen network. Note how you cannot see the elastin well in the lamina propria. In between these protein fibers and resident cells, the copious amounts of white space are filled with ground substance. Usually, the ground substance does not take most dyes or stains, so it appears clear. Adipose connective tissue is a bit interesting. The cells, called adipocytes, are actually pretty close to each other. They are considered loose connective tissue because of their adiposomes, fat droplets stored in large vesicles inside of the adipocytes. The protein fibers and the ground substance are only found at junctions between the adipocytes and are both relatively sparse. The final loose connective tissue is reticular connective tissue. The large image is a silver stain, and the smaller image is an H&E stain, both of the spleen, to show slightly different looks of reticular connective tissue. Reticular connective tissue features specialized reticular fibers composed of highly branching collagen proteins, instead of the long, straight collagen fibers found in areolar connective tissue. The ground substance is liquid in reticular connective tissue, allowing the flow of fluids through the mesh that the reticular fibers create. This is good for filtering fluids and is found in organs like the spleen and liver. In this image, the resident cells are lymphocytes that are attached to the reticular network to scan the flowing fluid for invading organisms. Dense regular connective tissue is the first dense connective tissue we'll discuss. Note that most of what you see here are linear protein fibers. Dense regular connective tissue is found under load in the body. When you cut it, you remove the tension of the load and the fibers contract, forming characteristic waves. Only elastic connective tissue has a similar wavy look. Between the numerous collagen fibers, there are very sparse amounts of ground substance. Occupying space between the fibers are the fibroblasts. The only structure you can make out is the highly elongated and compressed fibroblast nuclei. Dense irregular connective tissue, DICT, has the same basic components as dense regular connective tissue. It is organized dramatically differently, however. The large bundles of collagen fibers are semi-randomly organized, running in multiple directions. This makes DICT strong in multiple directions, but not nearly as strong as DRCT in one direction. We can see the collagen fibers running in several directions on the slide. Due to the semi-random organization, the ground substance and fibroblasts are not nearly so compressed. The white islands of ground substance are still sparse. The fibroblast nuclei are much more round. Elastic connective tissue has a somewhat similar look to dense regular connective tissue. The tissue is also under load, and when you cut it, the fibers contract and become wavy. However, here we have numerous elastin fibers that stain more darkly than the collagen fibers. Because the elastin allows the tissue to stretch and rebound, we can find more islands of ground substance. The fibroblast nuclei tend to be more numerous and round as well. Hyaline cartilage is the first supportive connective tissue. It has a clear, glassy matrix that is nearly uniform in coloration. You cannot see any protein fibers in the matrix itself. However, there are extremely sparse fibers present. There are near spherical holes in the matrix called lacunae that are occupied by the resident cells of the cartilage called chondrocytes. The cell is the chondrocyte, and the structure they occupy is the lacuna. Fibrocartilage looks superficially like dense regular connective tissue or elastic connective tissue. The matrix is relatively sparse and contains numerous collagen fibers, all running in the same direction. Similarly to DRCT, these fibers make fibrocartilage extremely strong in one direction. The major difference to look for here is the finding of the chondrocytes in lacunae. Neither elastic connective tissue nor dense regular connective tissue have cells in lacunae. It is a characteristic to cartilage only. Our final type of cartilage is called elastic cartilage, not to be confused with elastic connective tissue. Elastic cartilage possesses chondrocytes in lacunae, similar to other cartilages. The matrix is sparse, with abundant elastin fibers running through it. The biggest difference between elastic cartilage and fibrocartilage in their look is the orientation of the fibers. The collagen fibers of fibrocartilage are parallel and wavy. The elastin fibers of elastic cartilage are randomly arranged, creating a dark look to the matrix surrounding the light lacunae. Surrounding hyaline cartilage, and shown here around elastic cartilage, is a thick layer of perichondrium. Perichondrium is composed of dense irregular connective tissue and encapsulates both cartilages. Perichondrium does not surround fibrocartilage. The last type of supporting connective tissue is bone. Pictured as ground mature compact bone. Compact bone is organized into the Haversian system of osteons. An osteon is composed of a series of circular lamellae of hydroxyapatite bone surrounding a central canal containing nerves and blood vessels. At the margin of each lamella, you will find osteocytes occupying lacunae. Osteocytes are mature bone cells that maintain the two lamellae that they touch. Connecting the osteocytes to each other and to the central canal are a series of canaliculi that carry nutrients and wastes. Blood is the only fluid connective tissue that we'll see here. The matrix is composed of water and electrolytes and contains proteins that can form fibers during clotting. Since the protein fibers are present, even only transiently, this qualifies as a connective tissue. There are three classes of formed elements found in the blood. The most numerous are red blood cells or erythrocytes, composing the vast majority of our field here. The least numerous but easiest to identify due to the staining them very darkly are the white blood cells or leukocytes. Do not worry about identifying the individual classes of leukocytes at this point. The final class of formed elements are the thrombocytes. Thrombocytes are small packets of cells that contain clotting factors and stain a dark color.